In this video, I am going to discuss about the bulk modulus of elasticity. So in the last lecture, I discussed about the Young's modulus of elasticity. So basically the Young's modulus is the ratio between the normal stress by longitudinal strain. It means it is a change in length. In that case, the bulk modulus is basically the normal stress by the volumetric change, volumetric strain. It means some change related to the volume. So we know that what is the formula for the stress? Normal stress is stress equal to force per area. Okay. So we can also say that this is the pressure, and you can represent, because we know that pressure is the force per area. So this is the stress. Okay. So this is pressure, and we also know that what is strain. Strain in that case, volumetric strain in that case is the change in volume by original volume. So suppose this is a balloon, and if I applied force in this direction, then the size of the volume may get reduced. So I can say this is my capital V, original volume, and this is the small v, is the change in volume. Okay. So what is the ratio, what is the definition for the bulk modulus of elasticity? Is that it is the normal stress by the volumetric strain. So what is stress? Stress is the force per area, and we can also say this is the P, because P is the pressure. What is volumetric strain? Is the change in volume by the original volume. Now I am writing, this is B. So now I can write what is the bulk modulus. B equal to normal stress, this is force per area divided by volumetric strain, V by capital B. So what is F by A? F by A we can write P, now it is by capital B. Okay, so I can write B equal to P capital V by small v. So this is the formula for the bulk modulus. So what is the difference between the Young's modulus and the bulk modulus? Is that the difference is that in case of Young's modulus we use the change in length. Okay, it means the longitudinal strain, we use the change in length. But in that case, bulk modulus, we are considering the volumetric strain, it means the change in volume. So for change in length, Young's modulus is applicable, and for change in volume, the volumetric bulk modulus is applicable, and both are used to measure the elasticity of this material. Okay. So what is the formula for the bulk modulus? B equal to capital P, it means pressure, volume by change in volume. So again I am repeating that bulk modulus is the normal stress by the volumetric strain. What is stress? Stress equal to force per area. We can also say this is the pressure. What is strain? Strain is the change in volume by the original volume. Now what is B? B equal to, I can just put all these values in this formula. Then F by A, we know that F by A equal to P, and this is small v by capital V. So just reshuffling all this thing, and this is B equal to PV by small v. So this is the formula for my bulk modulus. So thanks for watching. Please like and subscribe my channel to get the more updates. Thank you.